All right, so we've talked about how to sketch angles in standard position, looking at reference angles and coterminal angles and negative angles. And now we're going to look at something that is similar, but at the same time different. And these are called, what we're going to look at today is the same type of stuff, but dealing with an angle measurement known as radians, which is defined by, if you were to take the radius of a circle and wrap that around wrap that around the outside of the circle, that would give us 1 radian. So like from here to here, that would be 1 radian, and then from here to here, that would be 2 radians, and so on and so forth. So a radian is just another way other than degrees to write angle measurements. So we're going to look at how many degrees there are, how many radians are there in degrees and things like that. So if we were to look at how many degrees are in 1 radian, well, if we think about this, we might say, well, that looks kind of like that looks more than a 45-degree angle. If you look at how many sections I have, 1, 2, 3, 4, 5, 6, all 6 of these are evenly like cut out because it's spread out through the radius, and then we have this like leftover piece kind of right here. So I know that there's 6 approximately equal sides, which if I do 360 degrees divided by those 6, that would be 60 degrees. Each one of these would be 60 degrees, like from here to here, 60 degrees. However, I do have this leftover piece that I have labeled with a question mark, so that's not going to be exactly 60 degrees. It's going to be less than that. So how can we determine how that is we're going to set up a proportion. But first, we want to look at the equation for circumference, which, if you can't remember what that is, if you get that confused with area, think about twinkle, twinkle, little star. Circumference equals 2 pi r, and that may help. But that's just to kind of illustrate how we come up with what we're going to do. So here's the equation for the circumference equals 2 pi r. And since the circumference of a circle is 2 pi times its radius, so a full rotation around the circle, then a full rotation in radians is 2 pi radians. So I shouldn't have that animation come up. So we're going to set up this proportion using 360 degrees and 2 pi radians. One of those is in degrees, one of them is radians. And if I want to figure out how many degrees are in 1 radian, then this is my proportion. I can simplify the left side and say 360 divided by 2 is 180 and get 180 over pi radians. And that will give me my proportion. So approximately how many degrees is 1 radian? Well, if I type into my calculator 180 divided by pi, I get 180 divided by pi. I get approximately 57.2357, blah, 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 blah. So, and that should make sense based off of looking at my terminal side at 0 degrees in that first radian. We said that it's more than 45 degrees, less than 60 degrees, and that seems like a reasonable answer, which supports what we said earlier. Okay, so we're going to talk about how to convert between degrees and radians today. We just saw how much 1 radian was in terms of degrees, but our goal is going to be to get our units to cancel from one unit of measurement to the other using this proportion right here, pi over 180 or 180 over pi. This is something that you do need to memorize, and which one we use depends on what we're given, what we're looking for. So we're going to start by setting up our converting by multiplying the given angle by one of the 2 ratios so that our initial angle will cancel and leave us with the desired unit. So for instance, if we start off with degrees, I'm going to use the pi over 180 degrees where I want 180 degrees in the denominator. And why is that? Because I'm given degrees to start with and I want my degrees to cancel. So if I write it like this, if I did 180 over pi, then the degrees would not cancel because I would have degrees in both the top and both numerators. Here they both cancel. So I can just do 40, and we never want to actually type in pi into our calculator. We just did that to see what 1 radian was approximately equal to. So we're going to leave pi. Think of it like how we would leave in x there, like 45x over 180. We can simplify our fraction. Our degrees are going to cancel, and that simplifies to pi over 4. So 45 degrees we know is in quadrant 1. Pi over 4 is also in quadrant 1. If we look at negative 210 degrees, I'm not going to make this coterminal and find a positive angle. We can have negative radians, so we'll leave this negative for now. And we can just multiply straight across and then simplify our fraction. So those degrees will cancel, and I'm left with negative 7 pi over 6. Here we're starting off with radians. This is what a radian looks like. We have pi's and fractions all over the place. Since we want our pi to cancel and we want to end up with degrees, we're going to do the 180 degrees over pi now. And we'll do that. We'll do 5 times 180 divided by 3 to get 300 degrees. For pi, we're going to make that equal to 180, or times that by 180 over pi. We'll do, the pi's will cancel, and I'll do 4 times 180 degrees to get 720 degrees. So before we go any further, that's how we kind of convert, but I want you to add some common radian angles around your spinner as well. So we've already discussed how much one rotation is. One rotation is 2 pi, so I want to label our spinner like one full rotation going counterclockwise is 2 pi. And let's think about labeling the same spots that we labeled the degrees. So if I think about going halfway around the rotation, what would that be? If I know one full rotation is 2 pi, what would half a rotation be? Well, that should just be pi. And let's think about, well, what about halfway between 0 and pi? What might that be? Well, that would just be pi over 2. Okay, let's think about the other one. What is halfway between 2 pi and pi? That would be 3 pi over 2. And so now we can look at some of the stuff and kind of see what we have going on. We're going to start by sketching the angle in standard position using the radians. And we're given negative 2 pi over 3. And before we actually kind of convert, because I would like to avoid you converting if at all possible, let's think about this another way. And if you need to convert to degrees to sketch these, and that's fine. We should note that this is going clockwise, so our rotation should be going this direction because our angle measurement is negative. But here's one way that we can set this up without having to convert. If we know that pi is equivalent to 180 degrees, and we have an angle like negative 2 pi over 3, we can take a 100-degree angle and divide it into 3 equally spaced, approximately equal spaces, and then take 2 of these. And that second part that we're dividing will be where our terminal side goes. So notice in between negative 180 degrees, that would be all the way over here, I've approximately divided this into 3 approximately equal spaces, and I want 2 of them. In other words, I want this second piece right here, and that would be that would represent negative 2 pi over 3 radians. Let's try another one. Oh, and that lies in quadrant 3. Pi over 6, I'm going to do the same thing. I'm going to divide in between 180 approximately into 6 evenly looking pieces, and I just want one of those pieces, which is going to be right here, the very first one. So just counting in order, I just want one of those, and this would be in quadrant 1, pi over 6. 11 pi over 18, this will take a little while to draw out, but I'm going to do 18 different markings between 0 and 180 degrees, and I want 11 of those. So just count up 11 of those lines, like so. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's the one I want right there. And that's in quadrant 2. If I do 7 pi over 6, I'm going to divide this up into 6 evenly spaces, but I go more than that, right? I go more than pi. So I'm going to go over into the next quadrant, and then I'm going to count 7, because this one will be these are approximately 6 evenly spaced sections up there, but this is 7 pi over 6. So I want to go, that would be 1, 2, 3, 4, 5, 6, 7. So I want that piece where I ended right there. And that would give me 7 pi over 6, which would be in quadrant 3. All right, I would encourage you to try this if you're doing this for the first time, but negative pi over 4, I would divide that up, and I should see well, first of all, I know that pi over 4 is in quadrant 1. So negative pi over 4 should just be in quadrant 4 right here. But I can divide this up into 4 approximately equal spaces. 1, 2, 3, oops. 1, 2, 3, 4, and I want one of them. And that will be in quadrant 4. If I do this next one into 12 evenly spaces, I'll have 12 spaces in between here. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 6, 1, 2, 3. Okay, and then I need 13 of those. Should be about right there. All right, so with coterminal angles, we looked at full rotation, adding and subtracting 360 degrees as many times as necessary. We talked about full rotation with radians would be 2 pi. So if I'm going to find an angle between 0 and 2 pi that's coterminal with this given angle, I can just add and subtract 2 pi from this. So the way we can do that is just keep in mind we have fractions here, and so I want to add something to where when we add fractions, our denominator has to be the same. So no matter how I look at this, I'm going to do plus 4 and then something in the numerator. But I want this to be equivalent, what I have right here, to be equivalent to 2 pi. So figuring out what that would be, that would have to be an 8 there, and then I can add these straight across. So I have negative pi plus 8, which would be 7 pi over 4. And that is coterminal. Finding a coterminal angle between the given angles, I want my denominator to say 3, and I want my numerator to say 6, because 6 over 3 is 2 pi, right? This needs to be between 0 and 2, so 3 goes into 10, approximately a little over 3 times, so I want to subtract 6 pi from that, and then I end up getting 4 pi over 3. All right, and then you guys have a Delta Math assignment 7.2 that you need to start on from here.